So what is a hypothesis? Okay, so usually for those who in my class, kebiasaannya normally I will ask you just some sort of like pop quiz lah. Once in a while you got called by your names. So this is just a simple way to to check for your attendance actually. So no marks given, but actually I just want to know whether you are present, not in spirit, but with your body. Okay, so I just want to ask you, okay, don't worry, don't scared by this. So my student always know this is my style, to know whether you're present or not in my class. Emalian Pinto. So what is hypothesis? What is a hypothesis? Are you here, Emma? So for today, maybe I would like to get acquaintance, get to know your biochemistry student, your friend from biochemistry. So Emma, are you here, Emma? Wah, so your microphone is so sayup. Okay, can you can you increase the volume? I don't know, maybe increase the volume whatsoever. Emma, where are you, Emma?
Yes.
Okay, so can you switch on your webcam? Boleh ke? Possible? Is it possible? Cannot. Okay, so what is a hypothesis? Can you tell me what is a hypothesis? A hypothesis.
Hypothesis is an assumption of the result, I guess.
Assumption of result. Apa dia? Again. Assumption of result. Again.
Yeah, it's an assumption. The result of the experiment.
You actually, hypothesis is you haven't done any experiment yet. Actually, So anybody else would like to try? Faris Nol Hakim. Faris Nol Hakim. Adakah? Ni yang minat Arsenal.
Yes, doktor.
Ni yang Arsenal punya fan ke? I pun dah lupa dah.
Betul lah tu.
Betul lah tu. Ingat lagi. Nasib baik kau bukan Man U. Aduh, okay. Alright. So apa dia? What is hypothesis? Sad to be a Man U fan tu nowadays. Okay, apa dia?
Hypothesis is like like the theory of
theory,
like what we expect from the experiment that we want to do.
What we expect from experiment. So hypothesis is not yet theory. If you prove your hypothesis, then maybe it's become theory. Not yet. Okay, so in a nutshell, okay, thank you, Faris. Thank you. A premise, a premise or claim that we want to test or investigate. So I make it into a word very simple for this afternoon. Very simple for you to understand. So this is like layman 101 for statistics. Okay, you can go read your notes, which is actually quite good. The note is quite good, but it's been done by someone else. It's a legacy notes. So this one is my version, the simplified version. So a premise or claim that we want to test or investigate, that's hypothesis. Okay. So in a hypothesis, usually there are two main things. The first hypothesis is null hypothesis. Null hypothesis denoted by H subscript 0. Null hypothesis. So null hypothesis is a value. If we talk about statistics, is a value that everyone thinks is the truth. A generally accepted truth. That's the null hypothesis. Okay. Maybe you have done some survey in the past, some investigation in the past, and that value is wholly accepted as the truth. Okay. Or other word, we can call this the status quo lah. Status quo. the status quo. Okay, so a wholly accepted apa nama ni value. Alright, status quo. Okay. Alright, so that's null hypothesis. Now, H naught will be H sub A alternative hypothesis. Now, the alternative hypothesis is sometimes called research hypothesis. Okay, this is the one that you want to prove. Okay, you came to me. Okay, sir, I have a hypothesis regarding certain things. Okay, and I will say to you, okay, go ahead, go and prove. Don't come back to me unless you have proven your hypothesis. So you go in the lab, 2-3 months down the road, come back. And usually you come back with a thesis because you have proved your hypothesis. Now you come back with a thesis, and that thesis you hand over to me in exchange with a degree. Hopefully you pass your bachelor degree. You hand over your thesis to me. Okay. So that thesis is already proven. Prove your hypothesis. Okay. So it's a research hypothesis, or sometimes we call this challenge hypothesis. You are challenging the status quo. You're challenging the status quo. So it involves the claim to be tested. Okay. HA is the one that you need to test. However, at this particular time, at this moment, I still consider H null to be the truth. It is still the truth, unless proven otherwise. Okay, you need to test your HA against your H null. Before you enter your lab, before you do your laboratory work or whatsoever, at that moment, H null is still the truth. It's just a simple example to demonstrate to you. Okay, what is H null and what is HA? All right, now, so it is believed that, okay, I make it into a statement so you know that how it works. So it is belief, okay. So I put a red marker there, believe that the machine that makes the Barrel's chocolate bar produce 5 grams of chocolate bar on the average. Okay. Now, a worker, a maintenance worker, now claims that after a certain maintenance done to the machine, the machine no longer makes 5 gram bars, 5 gram chocolate bars. Now, write the H null and write the alternative hypothesis, HA. Okay. Now, okay. So all this while, this machine in Barrel factory produce chocolate bar. The average weight of your candy bar to 5 grams on the average. So you are talking about some mu or X bar. Okay. So after undergoing maintenance, okay, the QC officer do some checking and say, hey, the weight is no longer 5 grams. Okay, now write the H null and also the HA. Okay. How you go about is, this is how you write it. Okay. So your H null, your existing hypothesis, the hypothesis that you believe all this while, we are talking about average here. On the average, the word here is average, so must be mu, or maybe you want to make it X bar, but usually it's mu here, equals to 5 grams. 5 grams. Okay. Now, oops, sorry. Quite sensitive. HA, mu is no longer 5 grams. Okay. That's how you put it into mathematical statement. Okay, to begin with. Now, one characteristic of hypothesis testing is usually the H bar, the H null and H alternative is usually, I call it mathematically opposite. The statement should be opposite of each other. Okay, mathematically opposite both statements. Now, after, let's say you come to me, let's say I am the manager of the Barrels Chocolate Factory, you come with that claim. Okay, and then I say, okay, go ahead, make a survey, do sampling, prove it to me. If your hunch is correct, we need to shut down the line. We need to repair. Okay. So possible outcome of the test of the sampling. So you take some sample and then you do some statistics, statistic calculation. Okay. Now, most probably, okay. If indeed the chocolate bar veer off from 5 grams on the average. So you can reject the truth. Okay, the H null. Given the evidence that HA is the truth, the new truth. So you promote it to the place of H null. Okay, currently the HA now is being promoted to the to replace the H null. Okay, you promote it. Okay, if you have sufficient evidence, statistical evidence. Okay, or you yet to reject, you still fail to reject the null hypothesis. You don't have enough evidence here. You don't have enough evidence here to reject. It's not to say that it's the truth. You cannot say that 5 grams is always 5 grams. But it's just that at that moment, maybe it's already veer off from 5 grams. But at that moment, you still fail to reject. Okay, you still fail to reject due to some insufficient, let's say, number of sample or whatever, or if your test, due to the nature of your test. Okay, you still fail to reject. Okay, how to prove? How to prove your hypothesis? How to prove that the chocolate bar is already less or more than 5 grams on the average, statistically different, significantly different. So you use what we call test statistic. Test statistic is a value calculated from your sample data, and then you input into some equation, some statistic equation that you use to accept or reject the null hypothesis. Okay. So how you go about doing this? You come to me with such a claim. You come to me with such a claim. Okay, and I say, okay, prove this to me. Prove this to me. Okay. So maybe possibly you as a QC manager of the factory, maybe you take 50 sample of chocolate bar. 50 sample of chocolate bar, and you get the average. What is the mu? And then with the number of the sample, with the average, and then you calculate into some test statistics. Test statistic. You need to derive some test statistic value, which depends on the problem that you have. Okay. Some problem require specific equation, like t-test, ANOVA, MANOVA, Kruskal-Wallis. Depends on the nature of your problems. Okay. How you pick your equation. All right. Now, let's say in hypothesis testing, the important things is what I call the term statistically significant. The word statistically significant. Okay. It means where do we draw the line to make decision? Okay, where do we draw the line to make decision? Whether to stop the machine, to repair again the machine, or just to let it run? Okay, okay. In this case of Barrel Chocolate Factory, okay, to make a 5 gram chocolate bar. Okay, just a simple example this afternoon. Okay, from your sample size, you have taken, you have sample 50. From 50 is your sample. Your population is maybe what, thousands. Yeah, let's say so many chocolate bars going out from the Barrel Chocolate Factory every day, into the tune of 1,000, 100,000. But you cannot afford to sample maybe 100 or 1,000 per go. Maybe lack of resources. Maybe the manager just ask you alone. Okay, prove to me. So you have to take a sizable numbers of sample. Okay, a sample is that has a size of 50. All right, that's your size. The 50 is 50 specimen. We call this 50 specimen in a sample. All right, now I took 50 chocolate bars, and then this is what I get. Okay, let's say Monday. Monday, I measure, I get 5.12 gram average. The mu, the average value on the Monday, 5.12 gram from 50 samples. Okay, now, do you think it's still okay to run the machine based on that 5.12 gram average? Do you still, if you are the manager, do you want to stop the machine or do you want to carry on your operation? Nordiana Zamri. Are you here, Nordiana Zamri?
Yeah, I'm here.
Okay. So what's your take on this? Simple saja. It's just attendance. 5.2.
Can you repeat your...
Okay, look at the slide. Okay, now I sample 50 chocolate bars from a Barrel Factory. Okay, okay. I assume that the average weight of chocolate bar is more or less than 5 gram on the average. Okay, so the QC said okay, so the chocolate bar that go to the market 5 gram. That's the QC. Now you say it's different already. Maybe it's too much or too little or too light, too heavy or too light, the chocolate bar. Now from that 50 pieces of chocolate bar in a sample size, now on Monday I do I weigh, randomly take sample 50 bars. I weigh and then I got average of the weight 5.12. Okay, is it still okay to you? This value? No. Why?
It's heavier than 5 grams.
5 grams is heavier. Okay. Okay. Now, do you want to be exact 5 gram or do you want to have a tolerance? Like confidence interval, acceptable one. Which one do you want? It's not like, you have to be exact. Everything must be 5 gram. If I'm a strict lecturer, I start at 5. Let's say, but you came in 5:15, 5:10, 5:30. Okay, if I do some survey, okay, 5 p.m. is your average, is your average. But I still have a normal distribution, plus minus how many minutes? Maybe 5:15. 5:15, 15 minutes is your 1 standard deviation. 5:30, 2 standard deviation. Okay, now what that becomes? That becomes a normal distribution, a bell-shaped normal distribution. So normal is still normal to you to come into my class at 5:30. It's within 95% confidence interval. Okay, but if you come at 6 p.m., it's no longer normal. Baliklah. Okay, alright, faham tak? Okay, 5.12. You must be a very strict QC officer. Okay, so berapa tolerance acceptable to you? 5 berapa? 5 point berapa acceptable to you? To go out to the market, the chocolate bar. So 5.12. Okay, so Diana say, that's the cutoff point. 5.12 cannot go to the market. Oh, but that's very strict. Okay, so now on Wednesday, okay. So this depends on the people. 5.72. Okay, another person sample on Wednesday. He get 5.72 gram. Okay, okay, larger than 5.12. Now, let's say Divian Mohan. Divian Mohan, are you here, Divian?
Yes, doctor.
5.72. So you want to stop the machine, or you say okay lah, it's still good. To me, it's still good to be let off to the market. Okay, for you macam mana? 5.72.
Yeah, I think it's okay.
It's okay, It's okay.
Yeah.
Okay, why? 5.72 is near to 6 gram already. Statistically speaking, you are no longer producing 5 gram chocolate bar, but actually you are producing 6 gram on the average chocolate bar. Okay, but for you it's okay. For you it's okay. Okay. Mani Magale? 5.72?
Yes. No, I wouldn't. It's not statistically. It's not.
Okay. You say it's not. Okay. You say
it's deviated from the actual value.
Okay. Okay. We still haven't say what is the actual value. Okay. Now Friday. Okay. Friday. Okay. One person go to the production line. He came back 7.23. 7.23. Salmira Gopala Krishnan. Salmira. 7.23.
Yes, Doctor.
Okay. Accept or reject?
That's like too far. Reject.
Reject. Okay. No need statistic. No need statistical test. That is an outright rejection. So what I'm trying to say here is, okay. Now, if presented with this data, some people may think otherwise. Let's say, okay, except for our friend, certain people may say, certain people will think it's okay, still okay, this value, 0.12 gram. 0.12 gram. You have to imagine this is an industrial size machine. No, it's not an analytical instrument to make a chocolate bar. If we are of 0.12 gram, consider okay lah. Okay. So your kids will be much happier lah. But more happy if they get 5.72. More chocolate content. Right? Okay, now. Okay, we have 2%. 2%. One still say some people thinks still okay. Still okay. To release that product to the market. Some people think not okay. Okay, you have two different view. Just just this moment ago, two people think differently. Some say okay lah, 5.72. Okay, our friend. And then Samira say, oh no. Okay, okay. So that means you have a different view. Okay, if you don't have any stats to rely on, some valid statistical number to rely on, you will face this problem. Some people say it's still okay. Some QC is very lax. 5.72 is still okay. Near to 6 gram already, not 5. However, most Most people will agree that this is statistically significant. 7.23 is way off from 5 gram. So you reject your rationale straight away. Without going into the detail of statistical tests, straight away you reject. Looking at that numbers. Okay. Now, is this thing that bugs you? Nak reject ke nak? Nak reject ke nak ni? Okay. So how do you rely on what is the parameter or what is the criteria that's okay before you march to my office? You must have some level of confidence to meet me. You must have some level of confidence. From your sampling, you take 50 sample, you do some statistics, maybe t-test or whatever, but 50 is already very big. Maybe you do some normal distribution test, Z-score, we call it Z-score. So usually the test is for for sample size that is less than 30, you do t-test. More than 30, you do Z-test. You do the normal statistical test, the Z-score. Now, let's say you take 50 sample, and then you did all your calculation, you march to my office. Okay. Before you meet me, the manager of burials to tell me that I need to stop my operation, my chocolate factory operation, because the chocolate bar is already out of the prescribed weight, the QC is already way off. You must have some level of confidence to meet me. Okay. Because this decision is money, economic decision. I need to stop operation of my machine. Now, Pang Ziwei is a random, don't worry, it's a random distribution, random sampling. Yes. Pang Ziwei, oh, it's a girl. Okay. Okay, I thought it's a boy. Sorry, my apology. All right, now, okay. Now, before you march into my office, I am the manager of Berin. We do some role play. What is your level of confidence before you come and see me? To say, okay, sir, we need to stop the operation, this machine. We need to have a maintenance, overhaul. How much is your level of confidence at that time? Berapa?
80. 80%.
50%. 50.
No. 80%.
80%. Okay, you must be 80% conviction when you come and see me. Okay, so Pang Ziwei, okay, 80%. All right, okay. Lim Chia Sun. Oh, ada boy pula. Okay, so how confident are you in meeting me? To tell me to stop my machine? How confident? How confident? Semangat berkobar-kobar ni.
85%.
What? How much?
85%.
85%. 85%. Okay. Slightly higher than Pang Ziwei. Okay. Nur Syazwani Zainuddin. Nur Syazwani. Takkanlah tanya orang biochem je. Orang bioproses pun kenalah. You are not out of my my status. Okay. Berapa?
85.
85. Oh, sama macam Lim. 85. 85. Okay. Okay. Siapa yang cakap tadi awal tadi 50%? Siapa yang cari 50%? Kalau you 50% je confident, I say get out from my office. Okay. You are only half confident. You must be full of conviction. At the very least, 95%. Remember? Okay. 95% confident. At the very least, statistically speaking. So when you came in with your data, you are only 80% confident or 85 at most. I will say, get out from my office. This is not conclusive yet. Okay. Your finding is not conclusive yet. Okay. So Level of confidence or confidence level, whatever, CL I put it. So it can be many numbers, 95%, 99%. That shows how confident are you to make that decision. Okay, depends. 95% usually is from the olden day, from the start of statistic. Okay, kenapa 95%? Orang dulu suka start at 95%. But it depends on the cases. It depends on the cases. Okay, meaning, okay, depends on the situation. So not many things you start with 95 as the de facto confidence level. Not everything, not everything. 95% means, okay, let's say based on situation. Let's say if you are a chicken farmer, a situation. Okay, let's say if you grow or if you rear some chickens, let's say out of 100 chicken, 5 dead, 5 chicken dead. Let's say you are doing some chicken farming, okay, out of 100 chicken, you try to grow, give them, supplement, okay, put them in a coop, hope to sell as a broilers or layers or whatever. Out of 100 chickens, 5 dead. You still have 95% success. It's okay. Due to your, the condition of your problem, 95% is okay. Okay. Out of 100, out of 100, 5 dead. Okay, 5 dead. It's okay. But if you are a heart surgeon, takkanlah out of 100 people that you operate or 5 people show dead. Boleh ke nak taruh confidence level macam tu? Out of 100 people that you operate, you are a heart surgeon, from 100 people, 5 show kaput. Right. So kalau saya as a hospital manager, the director of the hospital, do I need to employ you as a heart surgeon? Let's say if you out of 100 people that goes under the knife, with you in charge, 5 kaput. Surely I need to find some confidence level higher, 99% or 99.9. Dia tak boleh lah macam 95 kan. I must put higher, right? Right, 99%. Maybe out of 100, 1 KO. Okay lah, mungkin lah boleh lah kan. Kalau out of 500, because let's say we're talking about normal distribution, 100 people you operate 5 KO kan. Let's say kalau you orang nombor 96, how you feel? 94 people success, alive, you are the 96%. How you feel when you're meeting that doctor? How confident are you that your heart surgery will be successful? Rasa-rasanya awal-awal lagi dah dah book kereta mayat ke, catering untuk tahlil ke apa kan, macam tu lah kan, book tanah lot kubur ke, something like that, because you are not that confident with that surgeon. Okay, depends on the situation, right? Nanti dia belah you, nanti tiba-tiba the patient number 96 meninggal, dia tulis sebelah, dia kata it's normal lah kan, because it's normal distribution at 95%. Tell his colleague it's normal kan, because you take 95% as a significant level. Take 99. Now there's a compendium to the level of significance, level of confidence. We call this level of significance, usually you denote as alpha. Now alpha, very simple. Alpha is 1 minus confidence level. 1 minus confidence level. Okay. Either you define your your problem in terms of confidence level, or you define it in terms of alpha. Whichever suited you. Okay. Usually alpha is in fraction, in proportion. So let's say if you have CL of 95, usually we put it into fraction, means you have 0.95 confidence level. So alpha will be 1 minus 0.95. So your alpha, that's why you got 0.05. Okay. 0.05. Okay, so alpha also known as critical value. So critical value at 0.05. Okay, alpha is a probability. Okay, we later talk what is alpha. Okay. Now, you need to remember there are what we call biological hypothesis. Can be biological null or biological alternative hypothesis. There also statistical hypothesis. Statistical null and statistical alternative hypothesis. Now, usually because we are in biostatistics, so I need to refer or I need to invoke some example of biology, something lah. Okay, let's say biological hypothesis sometimes sounds like this. Okay, okay, it sounds something like this. Okay, so okay, so let's say you are a biologist. You came up with this idea. You came up with this notion that say the sexual due to sexual selection by the female chicks, maybe during mating season. So the chick has a food fetish lah. I don't know why. Okay, towards the male. So during mating season, let's say sexual selection by female has caused the male chickens to evolve to have bigger feet. Okay, so females prefer bigger feet in male chicken, in male rooster. Okay, during mating season. Okay, that's his observation. That's the biological alternative hypothesis. Because the null hypothesis will be, okay, whatever the gender of the chicken, whatever the sex of the chicken, male or female, the average feet, the average length of the feet is the same. Doesn't differ very much. But this guy, a biologist, say, okay, so he put in a statement due to his observation. Okay, he put into biological alternative hypothesis that say due to the sexual selection by the females, it has created males with a bigger feet. Okay, you know lah, guys, you always do something crazy to meet with a female. Maybe they strut their feather or whatever. So this time in the chicken community, they like bigger feet chicken, bigger feet rooster. Now, statistical hypothesis always follow biological hypothesis. So you need to make it into a statement that you can convert into mathematical statement later. So statistical hypothesis, in this case, the alternative hypothesis should be, we can say that male chicken should have different average food size than female. Male chicken should have average food size different than the female. So you can say the HA M1 maybe the male not equal to the mu2. The average feet for both is not equal. Okay, that's your mathematical statement. Now, let's say after you have done your observation, okay, you find there is weak evidence. You have a weak evidence to reject the observation. The observation might be made by this biologist. So usually, after you have done your test statistic, this is how you conclude the biological statement, the biological hypothesis. So you can say that if you fail to reject, means the average feet size for male and female is not much different. So you can say that there is no significant evidence to support that sexual selection caused male chicken to have bigger feet, something like that. Okay, you must you must relate to the process. You must relate to the incidents. Okay, in order to elaborate the statistical findings. However, sometimes if you have enough evidence to reject the null hypothesis, let's say statistically speaking, you gain significant difference in food size. But still is might not enough to conclude that actually sexual selection that cause bigger feet. Okay. So statistically, you can reject the null hypothesis, but don't jump the gun that say okay. So male has bigger feet due to the sexual preference of female chicken. So there might be other, other variable that come into play. Possibly, males eat more. Maybe that's why it has bigger feet. Or males exercise more, run around chasing the chicks. Okay, so that's why males are more fitter than the females. So there are many interpretation to that statistical statement. If you say you can, you arrive to a rejection of the null hypothesis. So what happened? So you still cannot say for sure that is actually attributed to sexual preference that the male has bigger feet. So you need to test further. So in this case, you need additional experiment to test your biological hypothesis. So biological hypothesis is slightly different than statistical hypothesis. Okay. Now we come to some exercise. Just on writing. Let's say if you are given a statement, how are you going to transfer into mathematical statement? Let's say this is like a previous barrel chocolate bar. Very simple statement. So let's say a company has stated that their straw machine, this is the drinking straw, not the hay straw. Okay, let's say their straw machine makes a straw at 4 mm in diameter. Okay, now a new worker believes that the machine no longer makes straws of this size, and he proceeds to sample 100 straws to perform hypothesis tests with 99% confidence. So to go about writing the mathematical statement, so you start by this hash null mu should be 4 mm in diameter. You can put in diameter, whatever. Your H hypothesis, so mu is no longer equal to 4 mm in diameter. Okay, and then you can go about say what is the sample size? Sample size 100. What is the confidence level? 0.99, which makes the alpha 0.01. Okay, that's the information that you can extract from this problem statement. Okay, exercise 2. Yeah. Now, doctors believe that the average teen sleeps on the average. So the word here average. So average here. Straight away, you know that this is to do with mu. So doctors believe, so this is the null hypothesis. Doctor believes that average teen sleeps on the average no longer than 10 hours per day. So your H null is the mu is no longer than 10 hours per day. It should be the mu equal or less than 10 hours per day, because no longer than maximum can achieve 10 hours. Okay, but a researcher says that they believe teens sleep on the average longer. So another hypothesis came in. It says you sleep longer than 10 hours per day. That's why you miss my class in the morning. You sleep more than 10 hours. Okay. Now, the characteristics of this statement, hypothesis statement, is these two don't overlap. Always remember, they don't overlap. That's why you have less or equal, and this one you have more. You don't have more than equal. It don't overlap. Okay, it never overlap. The H null and H alternative don't overlap. Okay. How However, if you put them side to side, side by side, okay, together they, if you put them side by side, put them side by side, it will tell the whole picture. Okay, it will tell the whole picture. It will never overlap, but if you put them like a arrange like a train or something like that, it will create a complete picture of the situation. Okay, now another one. A school board claims that at least 70% of the student brings a smartphone to the school. Okay, this is like secondary school. Maybe for university undergraduate student, maybe 100% nowadays. No longer less than 100%, maybe. Everybody has a smartphone, but in school, there are maybe some restriction. So this particular school, they say 70% at least. Their student bring smartphone to the school. But a teacher don't believe this number. They think he think this is quite exaggerated and believe it to be less. So he go about randomly samples 25 students to test at significant level of 0.02. Okay, now write the H null and H alternative. So in this case, you are not talking about average. Because the word here, at least 70% of the student is not average. So what they talk about here is proportion. So H null for the proportion of the student in that particular school brings at least 70%. At least 70% of proportion brings handphone. This is the H null. P more or equal to 0.70. Proportion. P stands for proportion. It's not average. Now H alternative. So this teacher thinks otherwise. So the proportion of student that actually carries handphone is less than 70%. So see the sign. It never overlaps. See the sign. So and then you can go about say the alpha here at 0.02, meaning the confidence level is at 98%. Then the sample size is 25. The information that you gain from this statement. Okay. Now we have not yet testing any hypothesis. So this is actually just a statement. You just extract the information. You are not yet testing, is this number significant or not? Okay. So you may ask, or the board may ask the teacher, okay, okay, you come back and then you show a report. Okay. If let's say 5 students out of 25 say they bring the handphone to the school. 5 from 25. So does it mean that the null hypothesis is correct? That you can does it mean that you can reject the null hypothesis? Because 5 from 25 is quite small number. Okay. How about 25 say yes? 100%. Does it mean 100% people or 100% student carries handphone to the school? Okay. How about if 19 say yes? 19 out of 25. Okay. How you make out from that numbers, that respondent? How you want to say that this statement agrees with the H null, or this statement can defy the H null? Actually promoted H alternative. Okay. So that's bring us to what we call p-value. Okay. Like the barrel chocolate example, if I ask a person whether 5.25 is considered heavier or considered extra weight than 5 gram. Maybe some people say, okay, still okay, you know, more content, more material or more content to the consumer. Okay, they have extra, you know, extra chocolate to munch. Okay, 0.25 is okay. Some people is very strict. They say, oh, no, we need to stop the machine. It's no longer producing 5 gram per liter chocolate. Okay, so it's a bit fuzzy. It's a bit fuzzy. For those that, you know, fancier, they say, ayah, ni nak tutup ke? Or still nak run machine ni kan? Okay. So statisticians rely on p-value, p-value to present their data. Okay, p-value. So what is p-value? Okay, so maybe you come to my office, you show your p-value. P-value. So what is p-value? P is probability, of course. P is probability of obtaining a sample more extreme. Oh, more extreme than the one observed in your data. The probability of obtaining a sample more extreme than the one you observe in your data, assuming null hypothesis is true. Okay. How extreme you have, you can get, assuming that null hypothesis is true. Okay. So p-value is used to trigger. This is a trigger mechanism to decide when to reject or fail to reject null hypothesis. When this p-value is compared to usually the alpha value. Okay, alpha value is we call type 1 error. But okay, that is the story for another week. Okay. So today we just talk about p-value first, for you to understand. Now, okay, p-value. Okay, let's say you have done your survey. So maybe your survey is follows normal distribution. Normal distribution. So I think Dr. Saufi already maybe explained to you. For normal distribution, the test statistic usually, so let's say we collect our data and then from the data we put into what we call test statistics. In this case, the Z-score. The Z-score. So this is your sample average. This is your population average. This is the standard deviation. Usually it's the S, not the sigma, the S. And this is the number of sample, the sample size. Okay, so this becomes your Z statistic or test statistic. So you need to, from the data that you collect, you consider the number of sample size, all the variability, all the variance, all the averaging. So you came up to a single value. You call it Z. Z. Now, okay. So let's say for a case, maybe we don't limit to barrel chocolate. So let's say for a case that okay. So let's say we have a situation. Okay, we have a situation where the null hypothesis is actually the average mu is more or equal to 0.15, more than 50%. Okay, take any situation that the null hypothesis is more or equal to 15%. Okay, so alternatively, you want to prove that the alternative hypothesis is less than 15%. Less than 0.15. Okay, so from this value, then you go about do your research, do your survey, do your sampling. Okay, so you come back to me. You come back to me with this value. So this value has considered everything from this equation. So boils down to this value. Okay, boil down to this. Okay, now straight away, if I look at the statement, problem statement, I know that this is which direction that gives the extreme value. compared to the data that you observe. Okay. So by looking at this, I know that the most extreme value will be to the left. Because I'm assuming you can see here that after you have done, after you have convert everything to Z statistic, so usually the middle one is your H null hypothesis. So this value of null hypothesis is actually 0. The middle value is 0, the null hypothesis. So you want to know how far that your data is from the null hypothesis. How far can your data be from your null hypothesis based from your sampling? So this is left tail because it describes less than 0.15. So at negative 1.34, this is the statistics that you have calculated. Okay. So this is the Z. This is the Z. Okay. Equal to negative 1.34. Okay. Where this came? From your observation. So you have taken maybe 100 sample and then you have calculate the standard deviation, and then you know that the mu is, okay, your mu is 0.15. Your mu is 0.15. Okay. And then your sample mu is different. So your sample mu is X bar. So you do the calculation. So this is what you get. This is what you get actually. Okay. So the probability of getting any Z or any statistics more extreme than your observation should be somewhere here. So this is your p-value. So this is your p-value. So maybe this covers, maybe if your Z is minus 1.5, something like that. So this covers the probability of getting a sample data more extreme than what you have observed. Okay. So what is the probability? So you need to calculate the probability. Okay. And this probability will later, you need to compare with the alpha value. So your alpha value may be 0.05. If you state your problem at 95%. So that's the p-value, the p-value that correspond to Z minus 1.34, higher or lower than the alpha. Again, that will be the significant test. Okay, for let's say, for normal distribution, usually they give the area of the p-value is probability, and probability is usually the area under the curve. The area under the curve, this is the probability. So the total area for a normal distribution, for a Z-score distribution, is usually equals to 1. 1, the total area. So that's why you got P equals to 0.05, 0.01, 0.00 something, right? Because when you add up everything, it represents the area under the curve. The total area is equals to 1. You want to know what is the probability of getting, this is Z. What is the probability of getting a reading less than this Z? Okay, this is your observed Z statistic. What is the probability of getting another value here, another value here, another value here? Okay, so the statistic has sum up everything up to the Z statistic that you have calculated. Okay, the probability of getting someone a lesser number, if you go to the left, is bounded by this area. Bounded by this area. And then, okay, so I may not have time for the Excel. Okay, I told you, maybe later I will demonstrate how to calculate the area under the curve using Excel. So the area here is 0.0901. Okay, yeah. So does your findings is statistically significant? Okay, so because you obtain a Z equals to 1.34, and then what is the probability of getting that Z? Okay, so from the Excel calculation or from the statistical table, it gives you a probability of 0.09. Okay, sometimes you use that figure to compare with alpha. Alpha, maybe you take alpha 0.05. Okay, so from that figure, so you want to reject or you want to accept the null hypothesis from that figure, based from your comparison between p-value and alpha. Okay, okay, maybe p is bigger than alpha. So maybe alpha is here. This is the alpha. Okay, alpha also is the area under the curve. Alpha is 0.05, but your p, your p is somewhere here. If I were to shade, it's actually also covers the alpha. So this is the p. What happened? Okay, so this is the p. Don't worry, 10 minutes more. Okay, okay. So from this, were you able to reject or accept the null hypothesis? Okay, okay. In this case, maybe it's still not significantly different. Okay, what happened? What happened? Okay, now for the right tail test. Okay, for the right tail test. Okay, right tail is when you look at this. You look at this. You look at this. Your alternative hypothesis is something bigger. Okay, bigger than 0.43. Let's say the question say, okay, something to do with 0.43. The null hypothesis is less or equal to 0.43, but the alternative is more. So you see, it goes to this direction. You are trying to find a probability more extreme than your observation to the right. To the right. So this is your Z that you observe. So what is the probability of getting a value more extreme than the one that you measured? So this is the probability. What is the extreme? The more extreme value than your Z stat is maybe here, maybe here, maybe here. But everything is cumulative into this area. Okay, I just want to tell that for this Z statistics, usually normal distribution takes or calculate area to the left. To the left. Okay, so you don't simply calculate Z equals to 2.78 and compute the area or compute the probability. It's not simple as that, because the normal distribution usually covers area to the left. To the left. See, if I shade, it's somewhere here. If I shade, if I were to just take this value, if I were just to take Z bigger than 2.78, actually I'm calculating the area to the left. To the left. So what you need to do is you need to know the area to the right, the probability of getting something more extreme than your observation. So what you should know is the normal distribution has this characteristic that the curve is symmetrical. The curve is symmetrical, meaning whatever at the right side, so let's say this is 0, this is your null hypothesis. Whatever at the right side is actually the area is identical to the left side. Okay, identical to the left side. So in order to find the value here, the probability of getting reading more extreme than the data that you have. Okay, so you just simply inverse the relationship. So from here, what is the opposite? The opposite mirror of this statement is P Z is actually less minus 2.78. Okay, so to know the value here, because you just want to know the area under the curve to compare with alpha later, this area is actually mirror image of this. So this is the statement that actually you need to include in your Excel to know the probability. So probability for this is actually P is actually 0.0027. Okay, so if you compare with alpha, let's say if you're in this case, maybe you take 95% as your confidence limit, then your alpha is 0.05. Judging from p value, the p is quite low, very small compared to the alpha. So most probably that your alternative hypothesis is more significant. So you can reject the null hypothesis. Okay, I stop share the this. Okay, just to show how you calculate. This is to end the slide for today. So so during my time, I need to refer to what we call statistical table. We have a booklet that lists all the z-score, binomial distribution, whatsoever, whatnot. Okay, but nowadays, we have, simpler version, simple way to know the p distribution, the probability. So just go to Excel. Refer to this question, the left tail test, the right tail test. So what you can do is, okay, you can see this Excel. Okay. For t-test and binomial test, I will touch later in the next following lectures. So this is the, boleh nampak kan? Can you see the Excel?
Boleh, Doktor.
Okay, last. This is last.
Boleh.
Oh, okay, bersemangat. Okay, macam nak buka puasa. Okay, right. So this is the left tail test. Okay, left tail test. The previous value. Okay. So for P, the probability of getting Z score less than minus I think it's less than minus 1.34. You just refer to the slide. Refer to the is 0.09. Okay, how you go about getting this value is this is the syntax. This is the command. So you if I were to click on this, so this is normal. This is normal. Norm for the normal distribution, you have S here. S actually stands for, let's see if I were to start from fresh. Okay, so normal, you have one normal dot distribution, you go for this one. So it returns a standard normal distribution that has mean of 0. So meaning you have convert all your data into z-score. The null hypothesis has 0 as the mu. So you, and then standard deviation of 1. Okay, so you click this. So what will be the z? You just click here, and then what will be the command? True or false. So you take cumulative. Cumulative means cumulative distribution function. So the probability of getting minus 1.34 or anything more extreme than minus 1.34. So it's accumulated. So you go for cumulative distribution function. So let's say if I were to include the probability of getting minus 1.4, which is more extreme than negative 1.34, so it's already calculated. So it's cumulative. So I just click true. True. Okay. And you get this. You get this value. The probability value of getting z-score less than minus 1.34. So this is the right tail. Right tail, if I told you earlier, you need to convert to the symmetrical, to the mirror image, to the mirror image to the left, because you cannot straight away calculate right tail distribution. You need to put into a mirror image as in the left tail. And this is the value, 0.002. Okay, if I were to straight away put 2.78, what happens? Let's say if I were straight away put 2.78, Z is more than 2.78. So what happened? Actually, I got a very huge area under the curve, 0.99, close to 1. Okay, so it's inaccurate to calculate for the Z statistic. In this case, in this particular example. So always convert to the mirror image. If you calculate the right tail, always convert to the mirror image of the left tail test. Okay. So I stop share for now. So in the week 8, if I'm not mistaken, we touch a bit more on the binomial distribution and t-test. Okay, so that's end for today. Okay, thank you very much. I hope everything is recorded.